Hello everyone, can you hear me? Yes, I just heard myself, so I guess you can hear me. Okay, I think we can get started with this episode. Oh, maybe let's allow a few more minutes to join. Well, okay, I think we can get started with this episode. Um, this episode is about a feature of the Chrome browser, which is the ability of running headless, which means running Chrome in the background without actually seeing the user interface, but having a full-fledged Chrome session running under the running into the terminal in this example. This is a feature that became stable a few weeks ago in the version 59 of Chrome, but previous versions are capable already of running headless Chrome. I prepared 5 very simple examples about performing some common functions with headless Chrome. You can check the repository at the URL on this terminal. So while I will comment the code and run the examples, you can follow these examples on GitHub at this URL. So before getting started, let's see what are what is the utility of running headless Chrome. There are a few examples of things you can do with headless Chrome. For example, you can automate testing. You can use it for web scraping, or just to, for example, introduce continuous integration in your build system. This lets you um, run your tests into Chrome without actually having to open the browser and click on elements and so on, and test your user interface, which is basically what you can do with Selenium WebDriver or with Phantom.js, which was now is a deprecated project, but has the exact same concept of headless Chrome. Okay, so to start the headless Chrome, we need to run Chrome, or in my case on Linux, Chromium, with the headless flag. The disabled GPU is it's needed because of a bug on the Linux version, which is being fixed. So we add disabled GPU just to suppress some error logging from the console, which would make some useless noise. And then, very important, we need to use the remote debugging port. I will explain very soon what this debugging port is. Okay, so I pressed enter. So we have a Chromium session running here in the background. We cannot see it. And we will communicate with this Chrome session through the remote debugging port, which is 9222. To communicate with this session of Chrome, we will use a so-called Chrome remote interface, which implements the Chrome debugging protocol for Node.js. So basically, this protocol is based on message passing between the debugger and the session, and through this interface we can send commands, we can watch the network, we can query the DOM and other debugging functions. So let's get started with the first example, which is about evaluating an expression. So we have this code which will interface with the remote session of Chrome. And let's see what this is about. So we import this interface, and we instantiate a new client. As you can see, we did not specify the remote debugging port, because 9222 is the default port, so we don't need to specify the port. And then we start this client, and let's see what this client does. So first of all, it enables this domain, which is called page, which basically unlocks the ability of running operation against the page. In this case, we need it because we need to navigate. So we need Chromium to open this URL so that we can inject script into it. This URL is from a popular news site which is called Hacker News, and in this example we will evaluate this simple expression, which is document.title, which will return the title of this page. So let's run it. Okay, as you can see, it returned the title of the page. So title of the document is Hacker News. This means that this expression has been successfully injected into the page. It has been evaluated, and the result has been passed back to our script. So the result is exposed here in the result.result object as the value property. So okay, one thing is important to notice here, and it's that the expression is actually a string literal. This is very important to understand because the Chrome debugging network protocol is based on message passing. So you can send just strings to evaluate. In the next examples, we will see more complex code which cannot be written as a string because it would be hard to read. And we will see how to serialize that complex function. But let's jump to the next example, which is click buttons, where we will see how to simulate a click. This is particularly important because it's an example of interaction between the script and a web page, which is the basis of any automation mechanism. This example is very simple. I prepared a very simple website which basically has one button, and you will click the button and the server will print that a click has been received from the user agent. So to run this example, we need to run the web server first. So I will run the server here. Okay, so something is listening on port 8080. And let's see very quickly what is running. So as I said before, it's running this simple website. So I click me, and the server is logging my user agent. Okay, so I'm running Chrome 58. As I said before, this feature became stable on Chrome 59, but for the purpose of our test, the version 58 is good enough. So let's see what happens if we simulate a click with our script. So I close this window. So very similarly to the first example, we will navigate through the local host on port 8080, and we'll inject this simple function, document.getElementById, click me, and then it will click on that element. So as you can see, this is the function that we are injecting, but it's not a string, because if I had to write it as a string, it would be very hard for me. So I wrote it as a regular JavaScript function. But before sending it into the page for being evaluated, I am serializing it this way. Basically, I create this serialized function that takes a function as its only argument, and then it returns the same function expressed as a string and expressed as an immediately invoked function expression. So basically, what happens here is that from this we get something like this, which is immediately invoked into the context of the page. So to sum it up, as the expression, we send the result of the serialization of click button, and let's see what happens. This is I'm clicking the button, and as you can see, the server printed on click from this user agent. You can immediately see the headless-chrome string here, which differs from the Chrome, just to prove that this click has been performed by the headless session that has been running and that we connect to through the port 9222. So this is the most simple example of automation that you can achieve with Chrome headless. So let's see another usage of an headless browser, which is web scraping. Web scraping means extracting information from a page. So scraping information off of a web page. We will see two examples of site scraping. The first example is scraping a static website, which means that the content that we are about to scrape are available as soon as the page is loaded as part of the HTTP request response. And so let's get started with this simple example. It's the third example, called static site scraper, and let's see what happens. We load the Hacker News website, and then we inject this simple function, sorry. Basically, we run a loop against all the DOM elements that match this selector. So all the anchors elements with class story link, and for each of them we get their parent, we get their link, the text content, which is the title of the article, and a link to the comments. And then we pass the results back as as a string, because as we have said before, we can communicate through message passing. So what we receive must be a string. Otherwise, we cannot handle it on the script side. So we can serialize and deserialize before sending data. Okay, so what we expect from this test? We expect to have an array of objects with the URL, title, and comments properties. So let's run it and let's see what happens. Okay, as you can see, the code has been injected and structured data has been returned to us. So we have URL, title, and comments. For reference, this is the content that we have just scraped. news.ycombinator.com. So we have the last element is an article from the Atlantic, and this is it. So we have injected this code into the page. We got all the anchor elements with the StoryLink class, and through all of them we got information. So this is particularly useful because we could, for example, reuse these values as response for an API call. For example, if we are building a news aggregating site, we could scrape headlessly some websites and then merge the results as an API response. So this is another interesting application that relies on a headless browser. Okay, so let's proceed with another example, which is scraping a website where the contents are not available as soon as the page has been loaded, but they are programmatically loaded. For example, the example that we have just seen, scraping a website, um, you don't you don't really need a browser to achieve that kind of scraping. For example, you could just scrape the HTTP response of the website and then scrape the content. So you don't need a browser because basically you don't need JavaScript. Let's see this example. If I do HTTP request to Hacker News ycombinator.com and then I see the content of the page here. So if I want to scrape, for example, the title of the page, I can just grab the HTML that I have received as a response. Okay, so there's no need to run this code in a browser, okay, because the information that I am looking for is into the HTML itself as soon as it has been loaded. But what happens if the content is loaded through JavaScript? That in that case, headless browser makes the difference because otherwise you could not achieve this. Let's see the example number 4. So I prepared a very simple website in this case too, and so let's run the example number 4. Okay, so we have this running in the example number 4, which is a simple site which lists 3 links. So these links have been populated programmatically by doing a request to our server. I called it stories, that responded with three links, and then the user interface has been populated based on this response. So if we want to scrape this website, we cannot do it in a static way, because what happens if I see the response here? As you can see, there is no trace of my stories here, because stories have been loaded programmatically. So that's why we need a headless browser. The dynamic site scraper example basically injects these simple functions and then returns a structured links object. But before doing this, it waits for 1 second. Please notice that this is not a really good practice to wait an arbitrary amount of time and then inject in code. But this is clearly not a production environment, so we assume that after 1 second it is guaranteed for us to find the results. So let's see what happens. Let's try running this example. Okay, it waited 1 second and then it scraped the website. Okay, if it did not wait 1 second but wait for, let's say, 0 seconds, it would have returned no results, because content is programmatically loaded. So let's see the last example for this episode of our Tech Talk about inspecting the network requests that occur on the website. For example, let's see what is a use case of this. I prepared a slightly different version of the stories example, which runs as usual on port 8080, which basically shows the three links, but the HTTP requests returns another information which is not used in the user interface, so it cannot be scraped off the HTML. But what if we want to use the information, which in this case is info.lastupdate? How can we scrape this information? How we can get this information? The Chrome network debugging protocol exposes a network object that can be used to interact with the network, so to interact with HTTP requests that occur from and to the website. Let's see real quick what this network is about. Okay, we can in this example we use the response received event, which means every time that a response is received, an event is fired, and we use the information, the response information, which is the HTTP status, the host, port, body, headers, and so on. Of course, we are not interested in all the responses, but we are only interested in the response of the stories HTTP call. So what we do here is to run this code only if the URL matches this regular expression. Okay, so only if the URL ends with slash stories. What happens when this response is intercepted? We capture it. So from this point going forward, we can use the response as it has been intercepted, as it has received from the website. So what do we do here? Since we can only use strings, since the body in the HTTP protocol is represented as a string, we parse it as JSON because we are sure that the response is JSON, and then we get the info object and the last update property. Let's run this example and let's see how it works. So we watch the network, and after 1 second we see that last update received the correct value. So maybe this way is not really clear. I am just realizing this now because it's parsed as a date. But let's see what happens. Okay, so if we print the bare response, we can see this timestamp, which is exactly what we get as a response of this stories API here. And okay, so this was the last example. You can find more information on these three websites that I printed here, and you can find on the GitHub repository that I linked at the start, at the beginning of this on this episode. Sorry. So I'm reading your questions. Ukran asks when and where we define the document. So I'm not really sure what you mean, but basically we do not define the document because the code, for example, this code, document title, is injected into the page. So document here refers to the document it is injected into. For example, if we load Hacker News, we see that document title is Hacker News. So you have to imagine that this string is what you write into the developer console. Okay? But I'm not sure if this answers your question. Are there any other questions? Osbert says that the network tool is useful. It actually is very useful. I do agree with you. Okay, so I guess there are no other questions. Oh, that is an interesting question, Sergey. Sergey asks, what about resource consumption? Actually, I don't know how to answer this because I did not profile the consumption of the headless Chrome. Where the main difference with Hujan is asking, is there any special difference between Phantom and this headless Chrome? The main difference is that Phantom has its own API to interact with an instance of WebKit running headless. The main difference is that this feels that using headless Chrome feels a little bit more native than Phantom.js because you use an API which is provided by the Google team itself. So, which is the same API that underlies the Chrome developer tools. So basically, it's not hacky as Phantom was, basically. And as I said before, I did not do any profiling of headless Chrome, but it feels like very faster than Phantom.js. But of course, this is just my impression. I did not measure um, performances yet. But this is an interesting point, so I will look forward this kind of profiling. Any other questions? Exactly. Headless Chrome can be summarized as full Chrome plus exposed API minus user interface rendering. So there is one thing to point out, and is that the Chrome remote debugging, which is the exposed API, is not a specific feature of headless Chrome. You can use that protocol, that exposed API with any Chrome session. Okay, so you can use that API with whatever Chrome session you're using. So a page that you're actually seeing, you can interact with that through through that protocol. Well, Hujan asks if does it support some detect points that are used to detect Phantom right now. Well, in Phantom.js, the Phantom platform injects some Phantom-specific objects into the context of the page, into the into the context of the page, and Chrome Headless does not do this because it's like running the regular Chrome without interface. So as I was saying before, it's not a wrapper of Chrome. It's not a wrapper of WebKit as Phantom was. So it has the exact same properties of the regular Chrome. But as we have seen in the examples, there are some properties that are slightly changed. For example, the user agent. The user agent, if we do not override it, is mentions the headless Chrome string into it, and this is something that Phantom does as well. But all the Phantom specific properties that are inject and objects and properties that are injected into Phantom.js are not available, of course, in Chrome Headless, and there are not um, there is no mm, there is no any extraneous object injected into headless Chrome. So for a detection point of view, detecting Chrome headless is harder than detecting Phantom.js. Basically, to answer your second question, all the features that are available on the regular Chrome are also available to the headless Chrome. So touch events, orientation events, and so on. Osbert asks, what happens to some JavaScript statements that are executed based on client X or some sort? So I guess you're talking about the mouse position. So what is the mouse position on a headless Chrome? This is a very interesting question, and I do not know how to answer. But I think we can quickly see how to what are the values that are exposed. So give me a second that I am editing a script so we can see live what happens. Okay, so I think we can edit. Okay, for example, we can well, actually, well, you in JavaScript you can get the mouse position when an event is fired. So I think we have to simulate an event, but when we simulate the event, we need to pass the coordinates of mouse, I think. So this is a so let's do a very quick example. For example, we can let's edit the click buttons example. So this is the app, the event listener. Uh, yeah, let's expose it as let's expose these values are post body. So let's see. Let's see X. It's page X, I think. Y. It's page Y. it should work out of the box. Let's see very quickly. This was the number 2 example. Why is rect body undefined? Oh, maybe I need to parse the response, the body, sorry. Well, you know what? I will do this. So I got lost. Yes, maybe I will do, without wasting time now, I will do this example offline, and I will share the result on the GitHub repository. So thanks for pointing this out. Well, getting document body client height is not really a good approach, I think, because that refers to the rendering of the page. And not the mouse position. Well, which is a simpler test to do, so we can do this very quickly. Client height. Okay. We do not need to run the fake server. Let's see what happens. Okay, so it got the 600. Not sure where this is coming from. Let's try with width. $785. Not sure where these values are coming from. Okay, so maybe maybe they are default values for the headless Chrome. This was an interesting thing to point out. Are there any other questions? Okay, no questions, so I guess this is it. I remind you of the GitHub repository for more information, and let's talk to you on Slack. Hi, goodbye.